So we've got some time for questions and answers. These are 5 of the CTBUH working groups dealing with seismic, shortening, wind, outriggers and foundations. These are some of the most critical issues that our engineers face today in designing tall buildings. And I wonder what questions you might have for them in terms of, is this the appropriate things where they should be focusing, where the council should be focusing their effort? So I'd like to open up the floor to questions. There's a microphone just behind.
My question is related to tower verticality from
Ahmad.
Mr. Sir. So my question is, up to what height we should take wind-induced deflections into account while checking the verticality of tower? I mean that suppose I am constructing a tower of 300 meter high. So whether the wind-induced deflections will affect the tower verticality at higher heights while taking the measurements, or what height we should consider for that? Yes. Yes. Wind or due to the sun, one side is the sun, other side is shade. So there are some deflections. So whether those deflections will become critical if we...
Generally, when we do the survey, we try to do it at a consistent time. Let's say, for example, 7 o'clock in the morning, where the influence of the sun is not so significant. Generally, that's important, obviously, for a steel building. The concrete building, sometimes, depending on the environment, don't necessarily tend to be as sensitive. But in terms of the wind, I mean, obviously, generally, if we have a very strong wind, we have to, generally, we try not to do much in there. So we try to do most of the survey at a quiet time where it is consistent and we kind of sure of what we are measuring. But does this answer your question? Or?
Yes.
But, yeah, but obviously if you have a building that sensitive, asymmetrical building, and that's constantly sometimes move with time because of its weight. Then if you wait too long, then it's too late. Then you have to come up with another correction program, you know.
And secondly, we are not getting any methodology for checking this type of verticality. I mean, very little literature is available, and we are finding problems.
Well, obviously, if you talk, there are two things. One is doing it through an optical survey method.
During the construction.
And then generally, you know where the geometric centroid of the building, and generally they can check that on a daily basis. For Burj Dubai, where we were careful because it's very tall, and any kind of wind movement could result in more than what we wanted, and we needed to survey. Then in that case, we used the real-time GPS monitoring system, where we have a total in combination with a total station to figure out where the actual location of the building is. But also we have tilt meters also to measure the lateral displacement of the building on a daily basis, and that get calculated. It depends on your problem. Some problems are more simple than others. Others are more difficult, you know. Yeah.
And my second question is about axial shortening of columns. Axial shortening in columns due to load during construction. So if the column is if there is axial shortening in the column due to the floors we are putting up at different levels, so this will induce a secondary moment on those columns. So is there any guideline?
Yeah, I mean, there's a lot of guidelines related to how you deal with it. Obviously, if you run it through your analysis elastically, you can include a lot of that. But in terms of the long-term effects, you have to be careful, assess it differently, and trying to impose that. But this is not an easy task because it's an iterative process where, you know, initially you may develop very large forces. When the member cracks, then you release the forces, and so you really have to look at it very carefully. But the best thing you can do in any kind of building is to reduce the differential shortening from the early design process. If you wait until you finish the design and trying to overcome it, then it's maybe too late, and it's really difficult to do that. So planning at the early design stage, it's going to be very important. Equalizing stresses between the members. Generally, if you do that, then you solve the creep, and that's about 2/3 of the problem is gone. And if the members are proportionally have a good, you know, similar shrinkage characteristics, then you overall reduce the overall deformation and relative movement. So it's all about planning at the early design stage. So don't let things wander until the end, then you definitely will have a problem. So you have to be careful.
Thank you, sir.
Okay.
Ahmed, while you're up, I have a question or two. What schedule do you think that you're going to be working to in terms of producing a document? And are you going to be looking at acceptable sort of differential movements in terms of floor levels and what is acceptable to the industry?
Well, I think for me, I always strongly believe, and I think engineers should not allow this problem, as I mentioned to him today, wait until the end and say, I designed the member for strength, and then come back later and say, I have a differential problem issue. That become fundamental to the overall concept. For Burj Dubai, for example, or Jinyoung Tower or Tower Palace, during the early development of the structural concept, we looked at the problem simultaneously to make sure that it doesn't translate into something we cannot deal with. In terms of the limit, obviously you can always do correction program, but depending on the methodology, how you evaluate it, you could be off as much as plus or 20%. And if you are not consistent in your analysis, you will definitely see that. So you have to, the engineer has to be very careful. It's an excellent question. The second one is, even if you correct for the problem, you have to be careful in terms of the relative shortening and also what impact it has on non-structural components, such as partition, cladding, and so on and so forth. So that can also result in another set of problems that does happen.
And the schedule? What's your schedule?
Well, the schedule, first I need to find the people. It's really, this is not an easy committee. That's the reason, I mean, an easy group. It's gonna do a lot of doing and a lot of summarizing. And it's very difficult to get a lot of people to go ahead with the right mindset, especially when involving different goals, different standards, different people, how they evaluate creep and shrinkage, different programs, different things. So, and also different measurements, and as you can see with it, all the different elements. So it's going to be a challenge. At this moment, I hope we can, once we find the people, we can have a clearer direction in terms of when we can finish that.
What type of data did you really rely on, and how reliable that data is?
So I think what Saba is asking about is in the probabilistic definition of ground motions and thinking about earthquakes that happen once every 500 years or once every 2,500 years or what have you. how do we know this given the fact that we've only been keeping records for 50 years? There isn't really a pragmatic answer to that other than to say that it's all based in statistics and probability theory. And so there are records, there's historical records dating back a couple hundred years, maybe 200 years, that aren't very robust. But this is, I guess, the best way to say it is the seismologist's best guess based on the data they do have and quite a bit of computer simulation of the known faults and the activity on those known faults. So I am probably not giving you the most solid answer, unfortunately. What we probably should have, if there was a seismologist in the house who could defend himself, that would be best.
Whilst you're up, I've got a question or two. You've got a very ambitious idea to build a consensus internationally, and I think that is exactly what is needed. Have you got a view of both the likelihood of an event like the one that hit Sendai on March the 11th? What kind of impact? Not necessarily that event, but the maximum credible, the big one in San Francisco. What would it, in your view, have impact would it have on tall buildings in America?
Well, the damage would undoubtedly be very extensive. The modeling that's been done, in fact, as part of these studies that were done as part of the PEER project, they looked at a variety of buildings, sample buildings designs, and interestingly discovered that buildings that were designed to the code, not using performance-based design methods, but actually designed to the current prescriptive provisions of the code, did better than we anticipated. And while there were problems with the buildings, they actually did surprisingly well. That said, I think the bigger issue in San Francisco or LA or any other American city for that matter is the infrastructure, in the sense that we're ill-prepared infrastructure-wise in the likes of water and sewer, et cetera, more urban design issues. I think this is evident in what happened in New Zealand. Their CBD, I understand, is still closed because of infrastructure problems. But going back to tall buildings in San Francisco, there'll be extensive damage. The big worry in San Francisco and the community's worry there is the housing stock. And the thought being that perhaps the housing stock ought to be designed for some higher performance objective. The sense being that if your office building is damaged after a major event, maybe you can work from home, or maybe you can find an alternative office. But if your house becomes unlivable or your apartment becomes unlivable and there's no place to go, this is a much bigger problem. So there is a group in San Francisco actually moving forward with a notion of trying to improve performance levels for housing stock.
Okay, shall we close it? If there are no further questions, we're going to close the session. I'd like you to put your hands together and give a big round of applause to the 5 leaders of the working groups. Without them, the council would be not nearly as a robust place as it is. Thank you very much.